In this video, we're going to be looking at velocity designed for NCEA Level 1 Mechanics in Science. Now, during this video, I'm also going to be referring to this set of flashcards here, and you can get a free copy from sciencescribe.co.nz. Now, velocity simply refers to a change in distance over a change in a certain amount of time. Now, during this year, you may have come across both these terms, speed and velocity. They are actually different. Speed refers to how fast something is going. Velocity technically refers to how fast something is changing its position in a certain direction. They'll stress this more in level 2 and level 3. If you can't wrap your head around it in level 1, don't stress yourself over it too much. Now let's say something is moving at constant velocity. If something is moving at constant velocity, that means its velocity isn't changing. It's constant. And if the velocity isn't changing, that means it's not accelerating and it's not decelerating, it's not getting faster, it's not getting any slower. On the other hand, if I have non-constant velocity, that means the object's velocity is changing, which means it is getting faster or it is getting slower, which means that there is an acceleration or a deceleration. Now let's say we want to do an example calculation. We've got a person that can run 100 meters in 9.58 seconds. That was Usain Bolt's personal record in 2009, and if I wanted to calculate his velocity, use the formula velocity equals distance over time, distance of 100 meters in 9.58 seconds, turns out he can run at a speed of 10.4 meters per second. 10.4 meters in each second. That's about the length of a classroom. He can get from one side of a classroom to the other side in a second. That's pretty fast. Now if we look at a distance versus time graph, the slope, the steepness, the gradient tells you the velocity. So here's a distance time graph there. Here's a straight line plot. If I wanted to work out the steepness in math, you may have come across that as using a formula called gradient equals rise over run. If I was to look at the rise component, I'm looking at the vertical axis, which refers to distance. The running component refers to the horizontal axis, which in this case is time. So when I take the gradient, when I take rise over run, I'm actually looking at rise distance over run horizontal, which is time. And that's why the gradient, the steepness, gives me the velocity. So the steeper that line is, the faster that object is moving.